Okay, so, when you hear about Bitcoin, like, everyone talks about the crazy price swings and the techie stuff, but under the hood, there's this awesome engine that's quietly working to keep a global network safe and secure.
It's Bitcoin mining.
Right, Bitcoin mining. And it's not about just making new digital coins. It's more like the heartbeat that keeps this system alive and trustworthy,
Yeah.
So for this deep dive, we've got some great articles that break down exactly what Bitcoin mining is and how it all works.
We're going to try to make it easy to understand.
Exactly. We want to cut through all the confusing parts and get to the cool stuff at the core of this whole process.
Right. And like a really important thing to understand is this idea that a lot of people have, they think the main job of Bitcoin mining is just to create new Bitcoins, like a factory or something.
Right.
But that's not really the whole picture.
No, definitely not. I mean, sure, those new Bitcoins are like a reward, but the main purpose of mining is actually to be the security backbone for the whole network.
Yeah, it uses a ton of computer power to do that. Think of the new Bitcoins as the incentive, the fuel that motivates people to use their computers to keep this system safe.
It's like a reward for keeping everything running smoothly.
Exactly.
And that whole security thing is based on this idea called proof of work. Can you break that down for us a little?
Yeah, basically, to earn those Bitcoins, the miners have to show that they've used a lot of their computer power to solve problems, like they've done the work.
It's proof that they put in the effort.
Right. It's really different from regular money where, like, central banks can just decide to print more whenever they want. It's like, imagine, having to run a marathon to earn a gold medal.
You have to actually earn it, not just have it handed to you.
Exactly.
Okay, I get it. So this whole computer work thing secures everything. But how does that actually work in practice?
Well, to add a new block of transactions to the blockchain, the permanent record of everything, and earn those Bitcoins, miners have to compete to solve these really hard math problems.
And we're talking like seriously hard math problems.
Yeah.
Like beyond human capability hard. Right?
Yeah, way beyond anything a person could do. That's where these special machines come in. They're called ASICs.
Okay, the ASICs. I've heard about those. What exactly are they?
They're special computer chips that are super efficient at solving these Bitcoin math problems, like thousands of times faster than a regular computer.
Wow, thousands of times. That's crazy.
Yeah, so they're constantly running, trying different solutions until they find the right one. It's like a global competition to crack the code.
So all these miners around the world, they're competing to add the next chapter to the Bitcoin story.
And get rewarded for it. Exactly. The first one to find the solution gets to add a new block to the blockchain, and they win those new Bitcoins, plus any transaction fees that were in that block.
So it's basically a race. And obviously, the more computer power you have, the better your chances of winning.
Yeah, the more power, the more tries you get at solving the puzzle.
That's why we hear about those giant mining farms, right? Those huge warehouses filled with computers.
Right, exactly. Those mining farms are full of ASICs running 24/7. But you don't have to have a massive farm to participate. That's where mining pools come in.
Right, the mining pools. What are those and how do they work?
Well, a mining pool is a group of miners who combine their computer power, so they have a better chance of winning. If the pool solves the puzzle, everyone in the pool gets a share of the reward based on how much computing power they contributed.
Ah, so it's like teamwork.
Yeah, like, if you're trying to win a tug of war, it's easier with a bunch of people pulling together.
Makes sense. But all this competition, how does it actually keep the network safe? Like, what stops someone from trying to cheat?
Okay, this is where it gets really interesting. Bitcoin uses this clever system called a consensus mechanism. So miners can't just add any old information to the blockchain. They have to check all the transactions to make sure they're legit. Think of it like a public notice board where everyone posts their transactions, and then the miners check them before adding them to the official record.
They're kind of like the guardians of the system.
Right, and if someone tries to cheat, like spend the same Bitcoin twice, the other computers on the network would catch them.
So it'd be like trying to sneak a fake bill into circulation. Everyone else would be able to tell it's not real.
Exactly. And the cheater would get nothing. They would have wasted all their time and energy.
So it's built to discourage bad behavior.
Right. For someone to actually attack the network, they would need to control more than half of all the computing power in the entire network.
Wow, more than half. That sounds almost impossible.
Yeah, it would be like trying to control more than half of all the computers in the world. It's super unlikely, and as the network keeps growing, it gets even harder.
It's pretty reassuring to know the system is that secure. But hey, I remember reading that the difficulty of this math puzzle isn't always the same, right? It changes. Why is that?
You're right. The Bitcoin system automatically adjusts how hard the puzzle is.
Okay.
So imagine if a bunch of new miners join the network, suddenly there's a lot more computing power, right? And they could solve the puzzle way faster.
And that would mess things up.
Yeah, it would create too many new Bitcoins too quickly. So the system adjusts the difficulty to make sure that no matter how many miners there are, it still takes about 10 minutes to solve the puzzle and add a new block.
Like a self-regulating system, so it prevents the system from getting flooded with new coins.
Right, and it helps control inflation.
And this all points to another key thing about Bitcoin. It's decentralized. There's no one in charge, no central bank calling the shots, right?
Exactly. It's all managed by the network itself, all these computers following the same rules.
So we've talked a lot about how mining keeps the network safe, but it's also how new Bitcoins enter the system, right?
Right. Mining does two big things. It secures the network and it creates new Bitcoins. It's how the miners get rewarded for all their work. And there's a limit to how many Bitcoins there will ever be, only 21 million.
Right, I've heard that. 21 million. So the reward for mining a block, it's not always the same, right?
No, it changes over time. It started at 50 Bitcoins per block, and it gets cut in half roughly every 4 years. That's called the halving.
So eventually the reward will get so small that the miners will have to rely more on the transaction fees.
Yeah, exactly. And even the term miner is kind of cool, right? Like they're digging for digital gold.
Digital gold, I've heard people call Bitcoin that.
Yeah, it's often called digital gold because, like gold, it's scarce and seen as a store of value. It's a fascinating system.
It really is. Okay, let's walk through the whole process of how a transaction actually gets added to the blockchain. Can you take us through it step by step?
Okay, sure. So let's say you want to send some Bitcoins to someone. That transaction gets broadcast to all the computers on the network. Each computer checks to make sure you have enough Bitcoins and that the transaction is legit. If everything checks out, it gets added to a list called the mempool. That's where all the pending transactions hang out.
Mempool, right. It's like the waiting room.
Exactly. Then the miners come in, they grab a bunch of transactions from the mempool, and they start working on that math puzzle we talked about. They're trying to find a special code called a hash. It's like a fingerprint for that block of transactions.
Okay, and the key to finding this hash is a random number they keep changing, the nonce.
Right. They keep plugging in different nonces until they find one that creates a hash that meets the network's requirements.
It's like trying different keys until one unlocks the door.
Exactly.
Yeah.
And once they find it, they broadcast that new block to the network.
And all the other computers double check it.
Yeah, they make sure everything's valid, that the transactions are legit, and the hash is correct.
And if everything looks good, then
It gets added to the blockchain. The miner gets their reward, and those transactions are permanently recorded.
it's amazing how it all works together. And this whole system, it's designed to create a new block every 10 minutes, right? No matter how much computing power is out there.
Yeah, that 10-minute target is important. It helps control how fast new Bitcoins are created.
We talked about that earlier, the difficulty adjustment.
Right, the system's always adjusting to make sure blocks are created at a steady rate.
Okay, and what about those halvings? You mentioned the reward started at 50 Bitcoins and gets cut in half every 4 years. What's the significance of that?
It's all about scarcity. As the reward gets smaller, it gets harder to mine new Bitcoins. This helps to control the supply and potentially increases the value of Bitcoin over time.
Like a built-in scarcity mechanism. So has mining always been profitable? You know, with the price of Bitcoin going up so much?
Well, it's more complicated than that. I mean, a higher Bitcoin price means more potential profit, but the halvings reduce the reward. And as more miners join the network, competition goes up, making it harder to get those rewards.
And like you said earlier, you can't really mine profitably with a regular computer anymore, can you? You need those specialized ASICs.
Right. The competition is fierce. People are always looking for an edge. And all those powerful computers working together, that's what makes the network so secure.
The more computing power, the harder it is to attack the network. But what about people who don't want to set up a big mining operation? Can they still participate?
Yeah, there are other ways to get involved. They can invest in Bitcoin mining ETFs, which are like baskets of stocks of companies that are involved in mining.
Okay.
Or they can join a mining pool and combine their computing power with others.
Like we talked about earlier.
Exactly. There's also something called cloud mining, but it's important to do your research because it can be risky.
Of course, always important to do your research. We can't forget about the energy aspect of all this. I mean, mining uses a lot of electricity, right? That's been a big concern.
Absolutely. Mining uses a significant amount of energy. It's a real cost for the miners, and it has environmental implications. That's why there's a big push for more sustainable mining, like using renewable energy sources.
It's a trade-off, right? The energy usage versus the
Right.
security and decentralization of the system.
It's a big discussion.
It is. So to wrap things up, Bitcoin mining is definitely a complex and evolving world. It's more than just creating new coins.
It's at the foundation of the whole Bitcoin system.
It's fascinating how it all works together.
Yeah.
So I hope after this deep dive, you see Bitcoin mining in a new light. It's not just some technical thing happening in the background. It's crucial for keeping this global network secure and trustworthy.
Right, definitely. And it's the system of competition, rewards, and constant adjustments that make it all work.
As you keep learning about Bitcoin, think about this. Here's a network spread across the globe, keeping itself secure and valuable without any central authority. What does that tell us about the future of digital currencies? What other possibilities does it open up? It's pretty mind-blowing. And as you learn more, don't forget to consider those economic and environmental aspects. They're all part of the bigger picture.
It's a fascinating journey.
It really is. Thanks for joining me today.
Absolutely.
We'll see you next time for another deep dive.